Hi, in this video we will discuss jobs in Kubernetes. We will try to understand what are jobs and why we need them in Kubernetes. So here we will assume that we have a Kubernetes cluster with a few worker nodes. So here we have the first worker node. Here the second one. And here is the third worker node, and finally here we have the fourth worker node. Okay. In most cases in Kubernetes, when we deploy applications, we want them to be always up and running. For example, when we deploy, for example, a web application, let's say that here we have a React app, and here we have this is the front end, and for the back end here we have a Django application with a MySQL database. So here, when we deploy those applications, we want them to be always up and running. Okay, so those applications can talk to each other inside the Kubernetes cluster using cluster IP services, and we can expose here the front-end application using a node port service. Okay, so what we want here is to make sure that if a user comes and try to access our application, he should find the application always available at any time. Okay, so here the application should be always at any time available for external users. Okay, and to achieve that, we can deploy those applications using a deployment. Okay, so here we can use a deployment for the React app, and another deployment for the Django app, and another one for the MySQL database. So here with deployments, we make sure that the application deployed using this controller, which is the deployment, will be always up and running. Okay, here for example, when we deploy the React app with a deployment, if this app goes down, here the deployment will notices that the pod running the React app fails, and it will create another pod. Okay, so now the users can access the app using this pod. But in other cases, we want to deploy applications, but we didn't want them to be always up and running. Okay, for example, we can here deploy an application just to perform a specific task in the cluster, and then we didn't need this application in the cluster anymore. Okay, for example, we can deploy an application just for collecting and compressing log files, and then taking them to the cloud. Okay, so the role of this application is just to collect and compress log files and then save them in the cloud. Okay, for example, we want to do this task every day at a specific time, for example at let's say at any time at 8 o'clock, for example. Okay, so here we want to deploy this app to perform this task every day at this time. Okay, and after doing its job, we didn't need this application anymore. So this application must be available in the cluster every day at 8 o'clock for performing this task. And then we didn't need this application in the cluster anymore. Okay. In some other cases, we want to deploy an application. For example, we want to deploy an application just for doing one thing in the cluster, and then we didn't need this application anymore. Okay, so we deploy this app just to do something only one time, and then we didn't need it anymore. For example, we want to deploy this application just for initializing resources like a database. Okay, so here we want this application to be deployed for what? For just initializing the database, for example. Okay, and after initializing the database, we didn't need this application anymore. In those scenarios, deploying the applications with a deployment controller is not a good solution, because this application, for example, if it is deployed with a deployment controller, after achieving and performing this task, this pod will goes down, but because it is controlled by the deployment, it will be recreated. Okay, so this pod, after performing this task, will goes down, but if it is deployed with a deployment controller, the deployment controller will notice the failure of this pod and will recreate the pod. Okay, so here we can deploy this application with the deployment controller. So here we want a solution to make sure that if this pod performs this task successfully and then terminates, the pod shouldn't be recreated. And if the pod fails before performing this task, the pod should be recreated. Okay, so here what we want to achieve to make sure that this task is successfully achieved and the pod was successfully terminated. And if the pod fails before performing this task, the pod should be recreated. Okay, and the solution here is to use jobs in Kubernetes. Okay, so jobs in Kubernetes are controllers that we use to deploy applications. Okay, we have two types of jobs. We have the first type is called simply jobs. Those are used just for deploying applications to perform a specific task in the cluster. Okay, so when we want to deploy a pod or an application just to perform only one thing, and then we didn't need this pod or this application anymore in the cluster, here we use the jobs. Okay, this type of jobs. And we have another type, and it is called CronJobs. CronJobs are used to deploy applications to perform a task at a scheduled time. Okay, so for example here, to deploy this application, here we need to use a job controller. Okay, so here the solution is to use this type of jobs. Okay, but here, because we want to perform this task by this application every day at 8 o'clock, here we need a cron job. Okay, so here the solution is to use cron jobs. So what we have to know here is that jobs are controller in Kubernetes used to deploy applications to a Kubernetes cluster. If you want to deploy an application just to perform only one thing, and then we didn't need this application anymore, here we need to use the type of jobs that is called simply jobs, which is this one. And if we want to deploy an application to perform a task at a scheduled time, for example, we want an application to do something in the cluster every day at a specific time, here we have to use CronJob. So that's it for now. In the upcoming videos, we will see jobs in practical, and I hope that everything is clear, and thank you very much.